Hello, my name is Steph, and today we'll be going over Forget Me Now.
Perfect. Let me
Forget
boot
Me
it
Now
up.
is it's not a boss module, although it's like a boss module. It's weird. It's also pretty hard. So, like I did with Uber module, I'm using the Spix Forget module
This is the
pack.
story of a man named Stanley.
I suggest you use it if you ever want to practice any Forget modules. So, the only thing we need is the serial number. So CR5JQ7. Now, unlike the other Forget modules, this one does not require the other modules to be solved. So, for
He had
example,
defeated the
this
machine.
doesn't change anything. In order to start this module, we will have to press any button. For sake of your convenience, I'd suggest pressing 0, and you'll see why in a second. And then it's going to be flashing numbers, and you have to write them all down. Or if you're in a voice bomb, you would have to just say each number. So, basically, what we're going to do is we're going to get a number from these functions, and we're going to add that to the number that we got from the display number. And we're going to take the last digit of that, and we're going to submit that back. For some terms that this module uses, the function ceiling means to just round up. So if you get, so let's say you have 6.1, that goes to 7. If you get, for the function, what's it called? Floor, I believe? Oh, this one doesn't have floor, never mind. I was thinking of an old version where it had floor function. Absolute value, you just remove the negative, and digital root, well, I just watch your Elias's tutorial on that. So, enough just speaking nothing. For this, since it's a function, it's going to require past inputs, well, past numbers. And for this, it says let u minus 1, which is going to be the answer for a certain stage. Let u minus 1 be the last digit serial number, so in this case a 7, and u0 be the number pressed to activate the module, so in this case we press 0. Now then, we followed these 3 rules for each stage. If either u minus 2 or u minus 1 are 0, which it is, since u of minus 1 is 0, or u0 is 0, then we're going to take the function of the ceiling function of h of n times the first digit of serial number divided by 5. And h of n, and so g of n, and and f of n will all be found here. So if you can read a graph, basically, I can't highlight this, unfortunately. If you can read a graph, then you're pretty much fine for this module. For n and x both mean the position, well, not the position, but the current, what's the word for it? The current number you're looking for. So since this is the first digit, x equals 1 and n equals 1. If it was the second digit, it would be 2, and it would be 2 for both n and x, and then 3 for 3, etc., etc. Now, so this says to take the h of n. So for h of 1 is going to give us a 1. And we multiply that against the first digit of serial number, so 5, and we divide that by 5. So 1 times 5 is 5, divide by 5 is 1. So the number we add is a 4, and 4 plus 1 equals 5. Okay, since now the previous digit that we input was 0, we still do this function. So we grab h of 2, which is a 2, multiply that by 5 and divide by 5, and that will give us a 2. 2 plus 0 is 2. So this is the function that I particularly hate because you get the same answer for each stage. And you'll see what I mean after this example. So what we do is we take this the square of x, and in this case x is 3, so times 3 squared is 9, and we multiply that by 2, which gives us 18. We then multiply that by f of 3, and in this case f of 3 is a 4, and 18 times 4 is 72. We then add these two together, so 7 plus 2 is 9, since we're taking digital root. And we add that with the previous two submitted digits. So 5 plus 7, 5 plus 2 gives us 7, and 7 plus 9 gives us 16. We modulo that by 10, and we get 6. And 9 plus 6 gives us a 5. Okay, since the previous two weren't both zeros nor both even, we go on to the next, we use this otherwise rule again. So, 4 squared is 16. Multiply by 2 gives us 32. And we multiply that by by f of 4, which is 3. And 32 times 3 is 96. The digital root of 96 is 6 because we can just cancel out any 9. And we add 6 with the last two submitted digits. So 2 plus 5 is 7, 7 plus 6 is 13, and we modulo by 10 to give us a 3. So the added digit for this stage is a 3. And we add these up together, and that gives us 9. Let's see. Okay, so like before, they're not both even nor both 0, or either 0. So we use the next. So we use this one again. 5 squared is 25. Multiplied by 2 is 50. And f of 5 is a 2, which gives us 100. Digital root of 100 is obviously just 1. And 1 plus 9 plus 5 gives us a 5. So 5 plus 7 gives us a 2. Again, we use this one. So 6 squared is 36. Multiplied by 2 is 72. And we multiply 72 by f of 6. And f of 6 is 5. And I believe that's 365, no, 360, but let me double check. Yes, 360. So 360, this digital root of that is 9. So we have 9 plus 9 plus 2. 9 plus 2 is 11, plus 9 is 20. 20 mod 10 is 0, so the number, so the answer for this stage is 6, since 6 plus 0 is 6. Now the previous two were both even, so we finally used this function, which is the absolute value of g of n times 4, so minus the total amount of stages. So g of n for 7, so gx, that is a 5, multiplied by 4 is 20, and subtract 7 is 13. So we modulo that by 10, and 3 plus 2 equals 5. So we have the final answer of 525. So
here we go.
5, 9, 2, 6, and 5.
We did it, Reddit.
So yeah, it takes a while, definitely.
Why?
Nope, I don't.
Yes.
7 plus 7, no.
Yes.
No.
He had defeated the machine.
Yes.
He had defeated the machine. He had
was
defeated
exactly
the
the
machine.
Now, I said before that that I don't like this function very much because the answers I get are the same. And what I mean by that is since it does not require the actual number you get for this part is like it gets pretty big. So once you get to stage 15, for example, so 15 squared is 225, and actually that's a bad example. So 14 squared, which is 196. And you have to multiply 196 times 3, and that's just pretty tedious. And to be quite frank, here's all the answers for f of n. I suggest you not to use it, and just do it legit. But if you want to be a cheater, then you can cheat, I guess. No one's stopping you. But that's my only gripe about this module. Let's do a bigger example.
This is the story of a man named Stanley.
This, forget me now, will be 31 stages. Our, let's see, our serial number is FR9HJ2. And like before, we're going to be pressing 0. F of F-1, well no, U-1 will be 2, and F0 will be 0. So, we have 8, then 1, then 6, and you'll notice it slightly increases in speed. So for not each stage, but at some point, oops, I forgot to write that down, 3, if I try to talk then I'm just gonna like forget a digit. So yeah, and at stage 25, it's gonna start going down a beat. 8, 4, 0. Let me just check log real quick, make sure that stage, what was it? 4 was an 8? No, stage something was a something. Right, so, like before, since the last digit that was supposedly entered was a 0, we followed this first function. So, h of n, which is a 1, multiplied by the first digit is serial number, so 9, and divided by 5. So 1 times 9 is 9, divided by 5 is, I think it's 1.5, I mean 1.8. 9 divided by 5, yep, 1.8. Rounding up, that gives us a 2, so the added digit for that stage is a 2, and 8 plus 2 is 0. Now we take h of 2, which is a 2, so it's 2 times 9 and divided by 5, that gives us 3.6. 3.6 rounded up gives us a 4, so the added digit for that stage is a 4. So, 1 plus 4 is a 5. Okay. And again, 2 digits ago we had a 0, so we're following this this function once again. H of 3 is a 3, so 3 times 9, which is 27, divided by 5 is 5.4. 5.4 is going to be rounded up to 6, and 6 plus 6 is 12. Mod 10 is 2. Now we take this function, since previous two weren't even, nor were there 0. So, n squared is going to be 16, I forgot the basic math. 16 times 2 is 32, and multiplied by, I believe it was 4? No, 3, or 4. Multiplied by 3 is going to be 96. 96, well, the digital root 96 is going to be a 6. And 6 plus 5 plus 2 is 13. So, mod 10, that's 3, and 6 plus 3 is a 9. Let's see. Again, since previous two weren't both even, we follow this. 5. Not 5. Yeah. 5 squared is 25, and multiplied by 2 is 50. F of 5, so it's 2 times 6. I'll just cut this all out. Okay. So, Since both of these weren't even, nor were either of them a 0, we're going to be using the last function. So 5 squared is 5 squared is 25, my bad, and multiplied by 2 is 50. 50 times f of 5, which is a 2, gives us 100, and the digital root of 100 is just 1. 1 plus 9 1 plus 9 plus 2 gives us a 2. So the added digit for that stage is a 2. And 3 plus 2 is a 5. Same thing as before, so we now have 36 times 2, which is 72. 72 times f of 6, which is a 5, gives us 360, and the digital root of that is 9. 9 plus 9 plus 5 is 23, and the last digit of 23 is a 3, so we have 5 plus 3, which gives us an 8. Again, neither were both 8. Well, they weren't both 8, basically. No, since they weren't both even, we're using the last function. So 7 squared is 49, and 49 times f of 7 is a 2. Wait, no, is a 2. And since we had to multiply this by 2, which I forgot to do, that'll be 49 times 4, which gives us 196. Which is, the digital root of that is a 7. Might just make sure I did this function correctly. 7, 2, 10, yeah. So, 7. 7 plus 8 is 15, and plus 5 is 0. So, 4 plus 0 is 4. Since they were both even, we use the second function. So, we take the absolute value of g minus 8, of g8, which is a 5. We multiply that by 4, which gives us a 20, and we subtract the total amount of stages, so 31. That will give us negative 11, and the absolute value of negative 11 is obviously 11. And that modulo 10 is 1. So 9 plus 1 is a 0. Okay. And since the previous thing was 0, we can go back to the first function, which is ceiling function of h of n times blah blah blah. So, since we already have this right here, we just need to get h of n of 9, so h of 9 is a 10, so 10 times 9, which is 90, divided by 5 is 18. Mod 10 is 8, and 8 plus 9 is 7. Okay, now we look at h of 10, which is still 10. So since the previous thing was 8 that we added, it also applies here, and 8 plus 4 is a 2. Now they weren't both even, nor were the last two 0, so we take this one again. So 11 squared is 121, multiplied by 2 is 242, sounds about right, and we multiply that by f of 11, and f of 11 is a 2, so that gives us 484, I believe. 484, 242 times 2, yeah. Digital root of that is 7. Let me double check that as well. Yeah, it's 7. 7 plus 7 is 14, plus 2 is 16. So so mod 10 is 6, and 3 plus 6 gives us a 9. F of 12, actually no, 12 squared is 144, and 44 times 2 is 288. 288 multiplied by f of 12 is actually 1, so this stays as 288. Now 2 plus 8 is, the digital root of 288 is 9. Yeah, it's 9. and 9 plus 2 plus 9 gives us a 0. 0 plus 7 is obviously 7. 13 squared is 169, a funny number, and we multiply that by 2. So 2 times 169, that gives us 338. 338 times f of 13 is still 338. So the digital root of 338 is 6 plus, how do I basic math? 6 plus 8, that's, so it's a 5. So 5 plus 9 plus 7, 5 plus 7 is 12, plus 9 is 21, so the added digit is a 1, and 9 plus 1 gives us a 0, meaning we use the first function. For h of, no, is it h? Yes, it's h. For h of 14, that gives us a 15. So, and actually from here on out, we'll have it as a basic value. So 15 times 9 divided by 5 gives us 27. So it's 7. So I just write this down, that h of x equals 7. So 7 plus 7 is 14, and mod 10 that's a 4. And since it's always 7 from now on, since as you can see this is a straight line, 7 plus 5 gives us a 2. Since the previous two were both even, we take the absolute value of g of n, so g of 16, g is the C outline, 16, we multiply that by 4, which gives us 64. And we subtract the total amount of stages, so 31. 64 minus 31 is 33, so the added digit for the stage is 3. So 3 plus 2 is 5. Previous two weren't both even, so we use the last function. Let's see. This is 17. 17 squared is, I believe, is it 343? That doesn't sound right. 17 squared is 289. So 289 times 2 is 578. And 578 times f of 17 is 0, which is a 0. And since anything multiplied by 0 is a 0, we add 0, 2, and 5 to give us a 7. And 7 plus 1 gives us an 8. So, let's see. Again, previous two weren't both even, so we used the last one. So this is 18 squared, which I believe is 200, I'm not gonna guess, 324. 324 times 2 is 648. The digital root of 648 is, is 18, well no, is 9. And 9 plus, wait no. No, I don't take the digital root yet. I multiply this by f of 18, which is a 1. And since anything multiplied by 1 is the other number, it is 648. And 648, the digital root of that is 9. And 9 plus 5 plus 8 gives us 22. So mod 10 is 2, 2 plus 2 is 4. And the previous two were both even. Now do notice from here on out that f of x is going to be 0, meaning we can just skip this part altogether and just add the previous two to get a new digit. So, let's see. So we take the absolute value of g minus n, well, of gn, so of 19, and multiply by 4, which gives us 44. Subtract the total amount of stages. I feel like I did something wrong here a while back. it's probably fine. I subtract the total amount of stages, and the total amount of stages is 31. So 44 minus 31 gives us 13. Yeah, I got 33 at some point. What's this? Hold on, let me double check my work real quick. Okay, my issue was, I did get something wrong here. This is, my added number here is actually at 9. So, 9 plus 2 is 1. And that changes the rest of these numbers. I'll get back to you once I get back to stage 19. So I fixed the past 3 digits. And good thing that since the last two are still both even, this answer still applies. So 44 minus 31 is some number. 13. So 2 plus 3 gives us a 5. And like I said, since from here on out, f of n is going to equal 0, we can skip this. So now we just add the previous 2 digits. So 6 plus 5 is 11, which is a 1, and 1 plus 1 equals 2. 5 plus 2 is 7. 4 plus 7 gives us a 1. 2 plus 1 gives us a 3. 8 plus 3 gives us an 11, which is a 1. 1 plus 1 gives us a 2. 2 plus 8 gives us a 0. And like, since... what was I gonna say? I forgot to actually mention this, but once you get past stage 20, all x's are treated as 20. So as you can see, the graph stops here, so we keep using the same values. So actually, h of x will equal 7 from now on. G of x will equal, let's see, so 12 times 4 is 48, I should have known that. Subtract 31, so 17. So g of x will also be 7. And the last function will be depending on these last two. So, on the last two submitted digits. So, 7. So, since it's 0, the last thing we want is a 7. The function we want is h of n, which will give us a 7. So 4 plus 7 is a 1. And 0 plus 7 gives us a 7. Since we're at f of x right now, that's going to be 0, so that's the last two added. So 1 plus 7 gives us an 8. 6 plus 8 gives us a 4. 7 plus 4 gives us a 1. And 0 plus 1 gives us a 1. 4 plus 1 gives us a 5, and 0 plus 5 gives us a 5. 1 plus 5 gives us a 6, and 6 plus 5 gives us a 1. 5 plus 1 gives us a 6, and 6 plus 7 gives us a 3. 1 plus 3 gives us a 4, and 3 plus 4 gives us a 7. And finally, we get to input this final sequence. So we have, I swear to God, if I messed up the first digit, so we have
here we go!
5, 2, 9, 5, 8, 4, 0, 7, 2, 9, 7, 0, 4, 2, 1, 4, 6, 5, 2.
Please, Stanley, think about what you're doing.
1, 4, 6. Okay, well, not that bad, I guess. So let's see what I did wrong here. So, this is stage 19. In stage 19, previous two were both even. So, actually, this doesn't matter. I'm not going to get rid of this just entirely yet, in case that my, what do I do? I press backspace, probably. I don't like Firefox. This is stage 19? Yes, okay. So let's see what I did wrong here. So, since previous two were both even, we take the g of x, so g of 19, so which is a 12, and 12 multiplied by 4 is 48, and subtract 31, that's a 7. So, our answer for this was supposed to be a 9. Let's see if this changed anything else. So previous two weren't both even. So we have 6 plus 5. Okay, this changed a lot actually. So I'll just delete this and delete this. So, let's see. Previous two weren't both even, so 6 plus 9 gives us a 5. 1 plus 5 gives us a 6. 9 plus 6 gives us a 5. And 5 plus 4 gives us a 9. 6 plus 9 gives us a 5. And 8 plus 5 gives us a 3. 9 plus 3 gives us a 2. 8 plus 2 gives us a 0. And since we have a 0, we use this function. So, 4 plus 7 gives us a 1. And 0 plus 7 gives us a 7. 1 plus 7 gives us an 8. And 6 plus 8 gives us a 4. 1 plus 7 gives us a 1. 4 plus 7 gives us a 1. And 0 plus 1 gives us a 1. 4 plus 1 gives us a 5. And 5 plus 0 gives us a 5. 5 plus 1 gives us a 6. And 6 plus 5 gives us a 1. 5 plus 1 gives us a 6. And 6 plus 7 gives us a 3. 1 plus 3 gives us a 7. And, 1 plus 3 gives us a 4. And 3 plus 4 gives us a 7. So, the last thing I input, 1, 4, 6.
Here we go!
9, 6. 93071. So 93071.
This is
Actually want to
incorrect.
stay alive?
Man, I can't math right now. 30. They put 1.
This
Here
is
we go.
Think
incorrect.
about what you're doing.
Okay, I just misclicked. Great. 7. 4, 1, 5. 1, 3, 7.
We did it, Reddit.
Did I not solve a digital root? Oh, I didn't. 2 plus, that is... no.
We
This
had
was
defeated
exactly
the
the
machine. Right now.
And that is Forget Me Now. If you have any questions, leave them in the comments. I hope you learned it. And get a job.